Hi, this is Nishon. Today my topic is inverse of matrices. We can find the inverse of matrix by different methods. Today I will teach one method and the other methods will teach inshallah in coming lectures. Inverse of 2 cross 2 matrix. You can find the inverse of 2 cross 2 matrix by the following formula. A inverse is equal to adjoint of A divided by determinant of that matrix. Adjoint of 2 cross 2 matrix. Adjoint can be simply denoted by the small alphabets A, D, J. Here I have a matrix A is equal to A, B, C, D. We can find its adjoint by the following method. First I will replace the places of A and D, and then I will change the signs of B and C. As here you can see that first B and C are positive, and after taking adjoint, the positive signs change to negative sign. Example is A is equal to 1, 2, 3, 4. Adjoint of A is equal to first replace the places of 1 and 4 and then change the signs of 2 and 3. So 2 and 3 are positive, and after taking adjoint, the positive signs will change to negative sign. Example of inverse of 2 cross 2 matrix. If I have a matrix A is equal to 1, 2, minus 1, 3, then we can find its inverse by the following formula. A inverse is equal to adjoint of A divided by determinant of that matrix. Now A determinant is equal to 1 multiplied to 3 minus 2 multiplied to minus 1. So 3 and minus minus is plus 3 plus 2. 3 plus 2 is equal to 5, which doesn't equal to 0. So if A determinant doesn't equal to 0, then we can find its inverse. But if A determinant is equal to 0, then we cannot find its inverse. Now adjoint of A is first replace the places of 1 and 3 and then change the signs of 2 and minus 1. So 2 is positive, then it will become negative, and minus 1 will change to positive 1. So A inverse is equal to put the adjoint value and then put the determinant value. So A inverse is equal to 3 by 5 minus 2 by 5, 1 over 5 and 1 over 5. Inverse of 3 cross 3 matrix. The inverse of 3 cross 3 matrix is little different than the inverse of 2 cross 2 matrix. If I have a matrix A is equal to 1 minus 2 1, 0 1 minus 2 minus 1 2 0, then the formula is A inverse is equal to adjoint of A divided by the determinant of A. Determinant of A is equal to, I will expand it by the row wise. First I take 1. Then in which row and column 1 exists, I will neglect it, and the remaining values are 1, minus 2, 2, 0. Then minus is of the formula and minus 2 is the second entry. Then in which row and column minus 2 exists, I will neglect it, and the remaining values are 0, minus 2, minus 1, 0. Plus 1, in which row and column this one exists, I will neglect it, and the remaining values are 0, 1, minus 1, 2. Now Now expand that by the 2 cross 2 determinant method. So 1 multiplied to 0, minuses of the formula, and minus 2 multiplied to 2. Minus minus is plus, so plus 2, then 0 multiplied to 0, minuses of the formula, and minus 2 multiplied to minus 1. Plus 1, 0 multiplied to minus 1 multiplied to minus 1. After solving, 1 multiplied to 4, plus 2 multiplied to minus 2, plus 1 multiplied to 1. 4 minus 4 plus 1 is equal to 1. Adjoint of 3 cross 3 matrix. Adjoint of A is equal to A transpose is equal to A11, A21, A31, A12, A22, A32, A13, A23, A33, where A is equal to A11, A12, A13, A21, A22, A23, A31, A32, A33. A transpose means the rows will become columns. So here in matrix A, you can see that A11, A12, A13 is a row, but in A transpose A11, A12, A13 is column. So all these rows of matrix A will change to columns in the A transpose matrix. And these A11, A21, A31, all these are the cofactors, and we have to find all these cofactors. Here I have a matrix A is equal to 1, minus 2, 1, 0, 1, minus 2, minus 1, 2, 0. Now the first cofactor in the matrix A, not in the A transpose matrix. In the matrix A, the first cofactor is A11. So the first column and the first row will be neglected, and the remaining values are 1, minus 2, 2, 0. Similarly, the second the second cofactor in the matrix A is A12, so the second column and the first row will be neglected, and the remaining values are 0, minus 2, minus 1, 0. And the third cofactor in the matrix A is A13, so the third column and the first row will be neglected, and the remaining values are 0, 1, minus 1, 2. Now in the cofactor A11, I wrote minus 1 power 1 plus 1. So minus 1 is of the formula, and in the subscript is 1 1. So I will put this in the power 1. I will add this in the power 1 plus 1. Minus 1 power 2 will give you positive, because minus minus is plus. And then open 1 minus 2 to 0 by the 2 cross 2 determinant method. So 1 multiplied to 0, minus of the formula, and minus 2 multiplied to 2 is equal to 4. A12 is equal to minus 1 power 1 plus 2. In the subscript here is 1, 2. So I will add in the power 1 plus 2. Minus 1 power 3 will give you minus. So minus 1 and 0 minus 2 and minus 1 0 will be opened by the 2 cross 2 determinant method. So 0 multiplied to 0, minuses of the formula, and minus 2 multiplied to minus 1. After solving, it will give you 2. Then A13 is equal to minus 1 power 1 plus 3. As here in subscript I have 1 3, so I add in the power 1 plus 3. And 0 1 minus 1 2 can be opened by the 2 plus 2 determinant method. So 0 multiplied to 2, minuses of the formula, and 1 multiplied to minus 1. After solving, it will give you 1. Now the next cofactor is A21. So in the subscript is 2 1, minus 1 power 2 plus 1. This A21 exists in the second row and first column. So neglect all these values, and the remaining values are minus 2 1, 2 0. Then open it by the 2 cross 2 determinant method. So minus 2 multiplied to 0, minus 1 multiplied to 2. After solving, that will give you 2. Next cofactor is A22, and it exists in the second column and second row. So neglect all these values, and the remaining values are 1 1 minus 1 0, and the subset is 2 2, so minus 1 power 2 plus 2. Open it by the 1 1 and minus 1 0 by the 2 plus 2 determinant method. 1 multiplied to 0 minus 1 multiplied to minus 1. After solving, it will give you 1. The next cofactor is 8 2 3, and it exists in the third column and second row. So neglect all these values and take the remaining values, which are 1 minus 2 minus 1 2, and the subscript is 2 3, so minus 1 power 2 plus 3. Minus 1 power 5 will give you minus 1, and 1 multiplied to 2 minus 2 multiplied to minus 1, so minus 2 plus 2 will give you 0. Then the next cofactor is a 3 1, and the subscript is 3 1, so minus 1 power 3 plus 1, and a 3 1 exists in the first column and third row, so neglect all these values. The remaining values are minus 2 1 1 minus 2. Open it by the 2 plus 2 determinant method, so minus 2 multiplied to minus 2 and minus 1 multiplied to 1. After solving, it will give you 3. Then the next cofactor is a 3 2, and the subscript is 3 2, so minus 1 power 3 plus 2. 3 2 exists in the second column and third row, so neglect all these values, and the remaining values are 1 1 0 minus 2. Open it by the 2 plus 2 determinant method, and after solving, it will give you 2. The last cofactor is a 3 3, and the subscript is 3 3, so minus 1 power 3 plus 3, and the a 3 3 cofactor exists in the third column and third row, so neglect all these values, and the remaining values are 1 minus 2 0 1. Open it by the 2 plus 2 determinant method. 1 multiplied by 1, minus of the formula, and minus 2 multiplied to 0. After solving, it will give you 1. Now put all these values in the A transpose matrix. Okay, now put all the cofactors values of A11, A21, A31, A12, A22, A32, A13, A23, A33 in the A transpose matrix. So by putting the values, adjoint of A is equal to 423, 212101. Now put values in the formula. Formula is A inverse is equal to adjoint of A divided by determinant of A. So A inverse is adjoint of A is 423,212 divided by 101 divided by determinant of A value is 1. So A inverse is 423,212,101.